Have you ever thought about how complex digital places, like, say, AWS, are actually kept secure?
hmm
Especially when you've got teams collaborating, resources being managed. I
Mm.
mean, how do companies make sure the right people access the right things?
Right. Without it becoming chaos.
Exactly. So today we're going to dive into exactly that. We're looking at
Oh, that's
AWS Identity and Access Management, or IAM.
hmm
Our mission here is to give you a really clear, strategic look at how IAM lets you control who gets into your cloud stuff and what they can actually do there.
Yeah, and maybe the easiest way to start thinking about IAM is like it's the key card system for a huge digital building, a really dynamic one.
Okay, a key card system. I like that.
Yeah, you as the admin, you're setting all the rules. You decide who gets a key card. Those are your IAM users.
Right.
Then, really importantly, you decide which rooms they can get into. Those are your AWS resources like storage buckets, servers, databases, you name it.
Makes sense.
And maybe the most crucial part, what can they do in those rooms? Can they just look, read things? Or can they change files, maybe even build new things? Those are the actions.
Gotcha.
And something people sometimes forget, but it's vital. IAM itself, the service, it's free.
Okay.
And it's absolutely fundamental for security. Preventing hacks, protecting data, meeting all those compliance rules, it's really the foundation.
So, okay, beyond just the technical side, why is this so important for you, the listener? Whether you're building things, managing things, or leading the team, what's the real advantage here?
Well, that's where it gets really interesting. When you look at cloud security overall, it's central. First off, it really helps you enforce what we call the principle of least privilege.
Ah, yes, least privilege. Heard that term.
Right. And it's not just jargon, it's a core security idea. You grant only the permissions someone or something absolutely needs to do its job, nothing more.
Okay, so minimum necessary access.
Exactly. This massively shrinks the area an attacker could potentially damage if, say, credentials get stolen. You limit the blast radiuses.
Right, limits the damage.
Yeah. If an app only needs to read from one specific place, least privilege means it can't accidentally, or worse, maliciously, delete something else entirely.
Makes sense.
Second, this gives you incredibly granular control. It's not just access or no access. You can get super specific down to individual commands or API actions, like view data, but absolutely cannot delete it.
Okay, very precise.
Very. Third, it's huge for teamwork and just scaling up. IAM lets lots of different people, different teams, work safely in the same AWS account because they each have only the access they need.
So different teams aren't tripping over each other or getting into areas they shouldn't.
Precisely. Think about your finance team needing billing access, developers deploying marketing looking at analytics all in one account, but securely separated by their permissions.
Okay.
And finally, and this is increasingly critical, compliance, GDPR, HAPA, PCI, DSS. These standards often require you to prove who can access sensitive data and track what they do. IAM gives you the tools for that control and the audit trails.
So it's not just about hoping you're compliant, it's about proving it.
Exactly, knowing it.
Okay, that really drives home the why. So let's unpack the how. You mentioned IAM organizes this through core components. We're focusing on three main ones today: users, roles, and groups, and then I guess the rules that tie them together.
That's right, policies. But let's start with IAM users. What is an IAM user? Well, fundamentally, it represents a person, an individual human, or sometimes maybe an application that needs its own long-term credentials to interact with AWS.
Long-term credentials, like a password.
Exactly. Each user gets a unique name and their own specific credentials. That could be a password for logging into the AWS console, the web interface, or it could be access keys.
Access keys.
Yeah, an access key ID and a secret access key. Those are used for programmatic access, like using the command line or scripts or software development kits, SDKs, to talk to AWS.
Okay, so for automation and tools.
Right, and these are meant for long-term persistent access. The beginner analogy we used earlier holds. Think of an IAM user like a permanent employee with their own personal key card. It's theirs, tied to their identity and job.
Got it. So like Sarah the engineer gets her own user account, her password, maybe keys for her tools.
Exactly. And you'd give Sarah's user account permissions, probably through policies, to manage, say, development servers, but not the main production database or billing info.
And if Sarah leaves.
You disable or delete her specific IAM user. Her credentials are gone, access revoked, without impacting anyone else. It's clean.
Okay, that makes sense for individuals or specific applications needing persistent access. But then you mentioned IAM roles. You said they're different. How so?
Yeah, they function quite differently. Roles shift the focus from a persistent identity needing access to a situation where access is needed, often temporarily, based on a task or a resource.
Okay, task-based, temporary.
Right. An IAM role is basically a collection of permissions. But critically, it doesn't have its own fixed password or access keys like a user does. Instead, something else, an AWS service, an application, even another user assumes the role temporarily.
Assumes it, like puts on a different hat for a bit.
That's a great way to put it. Imagine it
I hate.
like a temporary visitor's badge or maybe a special key given to a contractor just for a specific job in your building. They use it for the task, maybe access certain rooms, but then they hand it back or it expires.
Ah, okay. So it's not tied to who they are permanently, but what they need to do right now.
Exactly. This is super powerful for security because you avoid scattering long-term credentials around, especially for applications or services talking to each other.
Can you give an example?
Sure. Let's say you have an application running on an EC2 server that's one of AWS's virtual servers. And this app needs to write log files to an S3 storage bucket. You wouldn't embed permanent access keys into the application code on the server. That's risky. Instead, you create an IAM role. This role has a policy attached that says, allow writing to this specific S3 bucket.
Right.
Then you associate that role with the EC2 instance itself. The application running on the instance can then request temporary credentials by assuming that role. It gets short-lived keys, uses them to write to S3, and those keys expire.
Wow, okay. So the application gets the power it needs, but without holding on to risky permanent keys.
Precisely. It's fundamental for securing interactions within AWS.
That's a really key distinction between users and roles. Roles seem much more dynamic.
Mm.
Now, what about the third piece, IAM groups? This sounds more straightforward, maybe about organization.
You got it. IAM groups are all about simplifying permission management, especially as your number of users grows. It's about efficiency.
How so?
Well, instead of attaching permission policies, those rulebooks will talk more about to each individual IAM user one by one, which can be tedious and error-prone.
Yeah, I can imagine.
Yeah.
Especially with hundreds of users.
Right. So you create an IAM group, let's say a developers group. You attach the necessary permission policies directly to that group. Then you just add your individual IAM users for your developers into that group.
And they just inherit the permission.
Exactly. They automatically get all the permissions granted to the group. The analogy here is like a department in a company. Everyone in the marketing department probably needs access to the same set of tools and data.
Okay.
If marketing gets a new tool, you don't update every single person's access. You just update the permissions for the marketing group, and boom, everyone in that group instantly has access to the new tool.
Ah, that saves a ton of work.
A massive amount. So a company creates an IAM group called sysadmins, attaches policies allowing broad infrastructure management, and then just adds the relevant system administrators' IAM users to that group. New admin joins. Add them to the group. Done.
Okay. Users for individuals, roles for temporary service tasks, groups for managing user collections. But you mentioned the rules, the actual permissions.
Yeah.
That's IAM policies, right? That feels like the real engine here.
Absolutely. Policies are where the real control happens. They are the documents, written in JSON format usually, that explicitly define what actions are allowed or denied on which resources.
JSON, like code.
Yeah, it's a structured text format. Inside a policy document, you'll see key parts. There's the effect is this rule allowing something or denying it. And by the way, an explicit deny always overrides any allow. Security first.
Good to know. Deny wins.
Always. Then there's the action. This lists the specific AWS service actions, like s3.getObject, which means reading a file from S3 storage, or ec2.start instances, which means turning on a server.
Okay, the specific verb.
Right. Then the resource. This specifies which AWS things the action applies to. It's often an ARN, an Amazon resource name, which is like a unique ID for an S3 bucket or an EC2 instance or a specific user. So you can say, allow reading only from this bucket.
Very specific targeting.
Exactly. And you can even add conditions for more fine-grained control, like only allow this action if the user logged in using multi-factor authentication, or only allow it if the request comes from our office IP address range.
Wow, okay. That's layers of control.
Yep. And there are different types of policies. AWS manages some standard ones for common tasks or AWS managed policies, or you can create your own customer managed policies for your specific needs. You can even embed policies directly onto a user or role called inline policies, though managing lots of those can get tricky.
So understanding these policy documents is really key to mastering IAM.
It's The language of access control in AWS, absolutely.
Okay, so we've got the pieces: users, roles, groups, and the policies defining the roles. How does it all fit together in practice to make an AWS environment secure and manageable? Can you paint that final picture?
Sure, think of it as a layered system. You start with your IAM users, your people, your long-running apps, each with their own identity and credentials. You apply policies directly to them sometimes, but more often.
You put them in groups?
Exactly. You use IAM groups to manage permissions efficiently for users with similar job functions, attach policies to the group, add users to the group. Simple, scalable.
Okay.
Then, for tasks that don't need a permanent identity, especially for services talking to each other or maybe temporary elevated access for a user, you use IAM roles. Assign policies to the role and then allow services or users to assume that role when needed.
So users and groups for who people are and their standard access, roles for what needs to be done, often temporarily or by service.
It's a great summary. And underlying it all are the IAM policies. When any request is made, whether by a user directly through their group membership or via an assumed role, AWS looks at all the relevant policies. It checks. Is there an allow for this action on this resource? Crucially, is there any deny that applies? Because the deny takes precedence.
Right, deny wins.
Always. So picture that startup again. They create IAM users for employees. They put them in groups like developers or marketing, each group having policies granting necessary access based on least privilege. Their web application, running on EC2, uses an IAM role to securely talk to the database, DynamoDB, and file storage, S3, without any hard-coded keys. It all works together.
That really ties it all together. It shows how understanding these parts, users, roles, groups, and policies, lets you really architect for security and efficiency. It lets you control access and protect your data.
Absolutely. And it sets you up for good security habits, too, like always use multi-factor authentication, MFA, especially for critical accounts.
That extra layer of login security.
Essential. And regularly audit what's happening using services like AWS CloudTrail, which logs actions, who did what when, and use tools like IAM Access Analyzer to find permissions that might be too broad, especially ones granting external access you didn't intend.
So it's not just set and forget. It's ongoing management and vigilance.
Definitely. Security is a process.
This has been incredibly insightful. It really clarifies IAM, which, thinking about it, leads to a final thought for you, our listener, to ponder. As these cloud environments just keep getting bigger and more central to everything we do, how might really getting a handle on this kind of granular access control like IAM empower you? Not just to lock things down, but maybe to innovate faster, more safely, turning what seems like a security chore into a real strategic edge in these complex digital spaces.